This is part 2, where we're talking about models for logistic growth. Example 1 says a population grows according to the logistic equation given below, where t is measured in weeks. We have the differential equation dp dt equals 0.04 p times 1 minus the fraction p over 1200, where p of 0 is equal to 60. Part A says, what is the carrying capacity and what is the value of K? So remember from our equation above, M is our carrying capacity. And that basically just represents the limit. So notice that if you were to take the limit as t went to infinity of p of t, what ends up happening is this term right here goes to 0. So you're left with m over 1 plus 0, which is just equal to m. So that's what the carrying capacity is it's basically the limit of the population function as time goes on. So in this particular example, part A, our carrying capacity is 1200 because if we look back at the differential equation, the carrying capacity appears here, which is this value right there. We just want to make sure that our differential equation's in the correct form, which this one is, so we're good. And then our k value is here. Let me use a different color. So k is there, and then here is our k value. So that's going to be 0.04, and k is just some constant. All right, so for part B, it says write the solution of the differential equation. So we have p of t equals, and the general formula is just m over 1 plus a e to the power of negative kt. And off to the side here, I'm going to come over and calculate my a value, which, according to this, is equal to the carrying capacity minus the initial population over the initial population. And here our carrying capacity is 1200, and based off this piece of information, my initial population is 60. And then we are dividing this by 60. So if you simplify that, you end up getting A equals 19. So we end up getting P of t is equal to 1200, which is our carrying capacity, over 1 plus 19 e to the negative 0.04 t power. So that is our answer for part B. And then part C says, what is the population after 10 weeks? So now what I'm going to do is I'm going to take my population function and I'm going to plug in 10. And so anywhere I see a t, I'm replacing it with 10. Now, if you didn't have a calculator, you could just leave it like that. I have access to a calculator, and so if you throw that into your calculator, you find that the population that we're measuring is approximately 87. And it doesn't really say what kind of population we're measuring. We don't know if it's bacteria or people or some type of animal, so I'm just going to put 87 units. And that's it for example 1. Example 2 says, one model for the spread of a rumor is that the rate of spread is proportional to the product of the fraction y of the population who have heard the rumor and the fraction who have not heard the rumor. Part A says, write the ordinary differential equation that is satisfied by y. So the rate of change of the proportion of people who have heard the rumor with respect to time, so we have dy dt, equals, it says is, so that's usually the equal sign, proportional, we can put some proportionality constant, k, and then to the product of the fraction y of the population who have heard the rumor and the fraction who have not heard the rumor. So the proportion of people who have heard the rumor, we're calling it y, and then we have the word product here. So I'm going to multiply by the proportion of people who have not heard the rumor. So let's think about this with some easier numbers. So let's say there are 100 people, and let's say 20 of those people have heard the rumor. Then when we're talking about a proportion, that means 20% or 0.20 people have heard the rumor. So out of those 100 people, either you have heard the rumor or you have not heard the rumor. So that means that 80 people did not hear the rumor. And so the proportion of people would be 80% or 0.80. And notice that the relationship between those two numbers, let's say I knew that 20% heard the number, then 1 minus 0.20 is equal to 0.80, and that represents the proportion of people who have not heard the rumor. So in general, in here, I can replace that with 1 minus y. Part B says solve the differential equation. So we know that this is a logistic differential equation because I can rewrite my differential equation as dy dt times k times y times 1 minus y, and then underneath y we would put the carrying capacity, and basically it would be 1 because the maximum number of people that can hear the rumor is 100% of the population. 100% as a decimal is the same thing as 1, so I'm going to write it like that. Now, based off our formula from previously, we can get our solution, or we could also solve this again, basically integrating by separating, but that's a lot of work and we already did that previously, so why don't we just use the formula that we found in the previous table? So if you recall, the formula that I'm referencing is this one right here. So let's see, y of t is equal to the carrying capacity over 1 plus capital A e to the negative kt. And let's see if we can't fill in some of those values. I know that the carrying capacity we said earlier was 1. And then I have 1 plus, let's figure out what A is. So from earlier we had that the capital A is equal to the carrying capacity minus the initial population. And so in this particular instance, m is equal to 1. That's the carrying capacity. And we don't really have a value for the initial proportion of people who've heard the rumor. And so I'm just going to call it y sub 0 or y naught. And so that's what's going to go here. In my formula, I will replace A with 1 minus y sub 0 over y sub 0 times e to the negative kt. I'd like to clean that up a bit, and so one thing that I could do is I could multiply both my numerator and my denominator by y naught, just so that my formula for my solution looks a little bit nicer. So we get y of t equals y sub 0 over, I'm going to go ahead and distribute this, and we get y sub 0 plus y minus y sub 0 e to the negative kt. And that is our answer for part B. Okay, so I've gone ahead and copied my answers for part A and part B up above. Now let's move on to part C, which says, Mr. Kwan's hometown has 1,000 inhabitants. At 8 a.m., 80 people have heard a rumor that one time he was on the show Judge Judy because his dog bit someone and they sued him and he lost and cried in front of Judge Judy. By noon, half the town has heard the rumor. At what time will 90% of the population have heard the rumor? All right, so it says at 8 a.m., 80 people have heard the rumor. So let's just go ahead and assume that 8 a.m. is our starting time. And if that's the case, then I'm going to define my variable t to be the number of hours after 8 a.m. And if that's the case, then we have two helpful pieces of information here. So y of 0 is equal to 80, and that's another way of saying that y sub 0 is equal to 80. And then it also tells us by noon, half the town has heard the rumor. Oh, sorry. I made a quick error here. So at 8 a.m., 80 people have heard the rumor. And if there's 1,000 inhabitants, y is measuring a proportion and not a number of people. So earlier I put y of 0 is equal to 80, which is not true. So be careful, don't make the same mistake that I did. We know that at 8 a.m., 80 out of 1,000 people have heard the rumor, and as a proportion, that is equal to 0.08. So now y of 0 is equal to 0.08, and y of, okay, so by noon is 4 hours after 8 a.m., so that would mean y of 4 is equal to, and then half the town, so that's a proportion, we'd have 0.5 or 1/2. So those are two pieces of information that we have that are going to be useful to us. Now, if I come back to my solution, we have y of t is equal to, here, this is the same thing as saying y sub 0 is equal to 0.08. So let's plug that in. And then 1 minus 0.08 is 0.92, and then e to the negative kt. So the reason that we have this second piece of information here is we don't know what the k value is in y of t, so we can use this to solve for y of t. Okay, so y of 4 equals 0.08 over 0.08 plus 0.92 e to the negative k times 4, because it's at noon, which is 4 hours after 8 a.m., and we know that this is equal to 0.5. So let's use this to help us solve for k or something close to k, and you'll see what I mean by that in just a moment. So I'm going to take this equation that we have here, and I'm going to take the reciprocal of both sides. And then the right-hand side of my equation is equivalent to 1/2, and if I took the reciprocal of 1/2, that would be 2. Then if I multiplied both sides of my equation by 0.08, I'd get 0.08 plus 0.92 e to the negative 4k is equal to 0.16. From here, I can subtract 0.08 from both sides, and that's going to give us 0.92 e to the negative 4k is equal to 0.08. And then from here, we can divide both sides by 0.92. And we get e to the negative 4k is equal to 0.08 divided by 0.92 is equivalent to 2 over 23. And then from here, I could take the fourth root of both sides, or another way of saying that is raise both sides to the 1/4 power. And that's going to get rid of the 4 for us. So let's clean up the screen a little bit. All right, so from our previous calculations, we get that e to the negative k is equal to 2 over 23 to the 1/4 power. Now, from here, we could go about solving for k, but it makes our life a little bit easier just plugging it into the formula as is. So what we can do is we can replace e to the negative k to this e to the negative k here, and then just multiply the exponent by t. What do I mean by that? So we get y of t is equal to 0.08 over 0.08 plus 0.92, and then e to the negative k I'm going to replace with 2 over 23 to the 1/4 power, and then we're raising that to the t power. So essentially I'm just taking my exponent and I am multiplying that by t. Now, the question ultimately is asking, at what time will 90% of the population have heard the rumor? 90% is the same thing as 0.9. So what I want to do now is I want to take my solution and I want to set it equal to 0.9. From here, you would go about solving for t. It's a lot of algebra, so I'm just going to go ahead and say once you solve this equation, so this equation here, once you solve that for t, you end up getting that t is about 7.6 hours, or 7 hours and 36 minutes. So when we're answering the question, at what time will 90% of the population have heard the rumor, we can say 90% of the town will have heard the rumor by, and then we're starting at 8 a.m., so 7 hours and 36 minutes later would be 3:36 p.m. And that concludes this example.